Ever wondered how a smartphone board, with all its tiny components and multiple internal layers, fits into a thickness of less than a millimeter? The main secret isn't just a compact design. One of the most critical technologies is laser drilling. On standard boards, vias are created using mechanical drills. But when dimensions get incredibly small, mechanical drills hit a wall, both in terms of hole diameter and accuracy, as well as the risk of damaging internal layers. That's where the laser comes into play. In laser drilling, instead of mechanical pressure, focused pulses of light are used for the controlled removal of material. This means highly precise, clean, and incredibly small microvias can be created without putting direct stress on the board's structure. The main advantage of this technology is more design space. With laser microvias, designers can build high-density HDI boards, where signal, power, and ground traces must be managed within the smallest space possible. This technology is especially vital in smartphones, medical equipment, wearable gadgets, telecommunication modules, 5G systems, and high-frequency boards. But it's not just about smaller vias. Traditional through-hole vias can introduce parasitic effects like unwanted capacitance and inductance, which can degrade signal quality and negatively impact trace impedance in high-speed circuits. In contrast, laser microvias reduce these parasitic effects thanks to their shallower depth and shorter paths, making signal transmission between layers much more predictable and controllable. Of course, opting for laser drilling isn't just a manufacturing decision, it has to be planned right from the design stage. Factors like dielectric thickness, stack-up type, microvia diameter, spacing, and the overall layer structure must be designed carefully to ensure the board is both manufacturable and cost-effective. Ultimately, if you are working on a compact board, medical device, telecom equipment, 5G system, or any HDI project, laser drilling can be the defining factor between a mediocre design and a professional manufacturable board. If you're unsure whether your board's stack-up or via structure is suitable for laser drilling, contact the HDI PCB team through the link in the description to get a free review of your project's DFM file and layer stack-up. For more tutorials on PCB design and manufacturing, subscribe to the channel and let us know in the comments. Do you think the future of PCBs is possible without laser drilling?